Hi everyone. My name is Nkere-Awaji, and I'm here to present my dissertation demo. The title of my dissertation is Development of a Serverless Computing Architecture and Function as a Service Platform. And we'll be focusing on a platform as a service called lightPaaS, which I have built, which is a lightweight approach to serverless computing architectures and function as a service platforms. The motivation behind my project stems from my previous experience working with serverless computing. In my third year as a software engineer, I got exposed to serverless computing architectures, and where I had to build highly reliable systems using serverless computing architectures. And I got to understand some of its limitations, to cold starts, vendor lock-in, the baseline for high resource usage. And after my dissertation, after I've learned a few things in cloud computing, software engineering for service computing, amongst other courses, I had the idea of turning traditional functions into serverless functions where users would not have to be locked to a particular vendor, e.g. AWS, Google Cloud, and the likes, and where they also would not have to go through the stress of managing infrastructures. And additionally, I wanted to also tailor that to successfully run ML workloads. And during my research, I got hit with a lot of while researching. Unfortunately, there were unseen guardrails that helped steer me down this path of building building a lightweight, portable, and open source serverless platform. What are my key research questions? Can a lightweight, fast platform be deployed on constrained hardware with limited resources? How does this said platform perform under load in terms of scaling and latency? And what are the trade-offs that exist between that exist between commercial offerings? The methods and tools that were used to build lightPaaS, which is our platform as a service, serverless platform, is lightPaaS, which is built upon open FaaS, which is an open source function as a service architecture, running on K3, which is a lightweight implementation of Kubernetes, built by the folks at Rancher Labs, and tools used to visualize this are Prometheus, Grafana, and K6. Prometheus for grading metrics, Grafana for visualizing the matrix, the time series data, and K6 for running our load test to gather our experimental results. This is deployed on two environments, manually on my on an on-prem laptop, on an on-prem machine, which is a laptop, and programming language used to implement this is Golang, and our entire platform is a CLI platform. Yeah, our hardware setup, our on-prem machine is a MacBook Pro M1, and with 16 gigabytes of RAM and 1 terabyte of hard disk storage, with about 556 storage, 556 gigs free. And we also deployed this on a provision VM using Terraform and Ansible. So here is a quick demo to show how our system is deployed and how it also handles load. So back to the stage. Yeah, so this, you see how quick this deploys, and this is our deployed version here. we initiate the request again. So this sends, yeah, so we are able to have that running. Over here we have our monitoring dashboard, which shows our monitoring coverage, our requests per second, our first hit, latency, replica over time, observed CPU memory, and error rates. So we see here that our function lightPaaS node.io is fully monitored. And just to, okay, yeah, also this is a Prometheus dashboard, which shows we are capturing our metrics from lightPaaS. So I would run a very simple load test to simulate some workload. So yeah, we see how our system is faring. Back to our presentation. So for future work, currently we have our minimum replica as set to 1 and the maximum to 3 for scaling for scenarios where we have to scale. But having a minimum replica of 1 means that we would always have our function or deployed functions in always running. Um, this has its pros and its cons. One of which is one, we are always utilizing memory resources, but it's very it's kept at the bare minimum because most serverless workloads are not long running processes, but they're processes that are triggered based off of user needs. But what this means is that it's always going to be highly available. So we are already mitigating cold starts as a result of that. Then we also need to better handle dynamic auto scaling. And as I mentioned earlier in the beginning, I had the plan on optimizing this for ML workloads, but as a result of time, I couldn't do that. And also for figuring out how we can dynamically reduce um, um, the image size of our deployed containers, which would also influence how fast our service actually boots up, and how that would also help reduce cold starts. In conclusion, we've been able to show that lightPaaS shows feasibility for running serverless applications on with very with minimal resources and minimal infrastructure, running on K3 as opposed to running on a large scale Kubernetes. And there are still a few trade-offs, obviously, compared to commercial grade function as a service platforms. And what this contributes is an open source portable platform as a service prototype, where teams and students alike can run experiments and see how respective serverless workloads can actually run in a serverless environment. And this could also be tailored for edge for edge devices like Raspberry Pi and things, because it's lightweight, and also for can also be deployed on resources that on environment with constrained resources. One thing I also did not show is how we are able to also, while this is still running, how we are also able to handle our VM deployments, which makes our experiments highly reproducible. So we would go into infra. So here we have Ansible and Terraform. Terraform is our infrastructure as code tool that helps us provision our VMs, and Ansible is our automation tool that helps us install all our dependencies for lightPaaS. So we'll give you a very quick insight into Terraform. Yeah. So yeah, this shows our compute resources. We have this port open. 8080 is our gateway ports. 9090 is Prometheus gathering ports, and 3000 is Grafana ports. Here is 2020, and obviously this also contains our entire. This is basically our entire infrastructure as code, and we'll see how this is applied. So Terraform apply. Yeah, so we see here our public IP and our SSH user. So if we SSH into lightPaaS, so we see here, yeah, we also have lightPaaS installed, and yeah, this shows that we obviously we've pre-installed this while running lightPaaS, and just for the sake of this demo, we're showing that lightPaaS is already set up in our VM as well, and you can also verify our VM resources here. So here's never mind our billing expenses. We've deployed this a while back. So here external IP, which corresponds to what we had. So yeah, that's it. Going back here, and yeah, thank you for listening.